Hello and welcome everyone in LabVIEW exercises. Today's video is all about creating a mathematical model or a simulation in LabVIEW so that everyone who just starting LabVIEW programming can just go through with a program that gives a basic idea of how LabVIEW programming is simple and easy to use. So in this exercise, basically what we are going to do is we will follow the instructions that is provided to us. So we'll glide through these instructions and one by one we will build up a system or a simulation. So this will be for all those people who is just starting the LabVIEW programming and want to learn how we can guide through or create an application level projects. So first thing first, I will just open a new file and then we will see I will try to create this again by following the same instructions in here, right? So I will open a new VI. Here what are the instructions are. So basically we have two equations, a fluid flow and the thermal equation. What we want is we have to follow these instructions. The program should satisfy the following requirements. Once the user runs the program, a pop-up prompt is shown to user asking him to specify the tank's safety requirements. So I will return back to my front panel, and then I'll go to block diagram, let's just say, and then I'll go to application control and the dialog user, and then I'll find out the prompt user here, and here I'll place it and automatically pops up a new window in here where I have to mention the names. For example, here I'm giving the name of head, and then I'll insert, and here is the temperature. You can also give any units to it as well, like degree centigrade or anything else like head in meters that was written, or it is all just up to you to just show it. So these are the numbers that we can give, and here is the message: select the maximum values or the constraints or the boundaries. Alright, so now it is set, and now it is giving me the temperature and the head. So this one point is completed. These values cannot be changed unless the program is rerun again. Those values should be shown to the user in the front panel. Obviously we are going to show those as well. So for that purpose we will go to, let's just say I go to front panel, and then I'll go to silver, and there I'll show this numeric indicator. So this will be my temperature max, right? And here it is this, and then I'll make a copy by pressing Control and then dragging it, and then here I will show the maximum head max. Alright, so here it is like this, and now I can just connect it back with it. Now we can just jump on to our next. The user can choose to work the fluid system or the thermal one. So again we have an option in here. We'll go to front panel, and then we will go to the layout. Here we'll find out the tab control. So let's just place the tab control in here, which will allow us to switch between the thermal or the fluid system. So let's just say the first one I will choose is the fluid system, and the second one what I'll select in here is the thermal one. So here I can switch between the two windows, and I can also remove its label, which is showing me tab control, which has no purpose. So here are the values, the maximum, and here we can select out. And then the next thing is, if the fluid system is selected, the user can specify the inputs like the magnitude, the initial head, the resistance, and all those things. So I'll again go to silver and I'll place a numeric value, a numeric control in here. So first thing is, let's just suppose that I am placing in here a input magnitude qi. Similarly, we can place all the other stuff as well. So for each system, we have to set up the step input or an impulse input. The user can see the change for the selected input of the fluid system as a tank indicator and a thermometer indicator for the thermal system. So we must have to set this as well. So for that purpose, I will go to silver, and then again we have different options from the different sections, but again silver ones seems a little bit quite a more good ones as from the visual perspective. So we can also show its digital display as well. So I can place that on this side so it will be look better. So again, for the fluid system, we have to show a tank in here. So again, I will open it and go to silver, and or instead of silver this time I will go to system or a classic one, and there I will find out a classic tank which looks more better than a normal one. So here I'll again increase its size. I could place that in here, and then again visible, instead of this label I'll use this digital display in here, which will also show me the value. So again, if we have to check it out, we have to give the two inputs in here, the step input or the impulse input. So we must have to select something in here. We must have to set out something that we can select, either it is step or impulse. For that purpose, again I'm going to classic, and here I could find out about this horizontal switch. So I can just place this out in here. Let's just say this, and I'll write select input type. Right here I can do one more thing, like I have to mention which one is step and which one is impulse. So I'll just simply write step, and then I'll write impulse. I'll place the step on this side. Let's just say the off side of the switch is our step input, and when it turns on, then it shows us the impulse. So now I will group those so that it won't move. Like whenever I try to move this whole switch, this will show me the whole step input and input impulse both together. So now we have set up our front panel. Now we can check what are the other requirements. The fluid tank indicator and the thermometer indicator shows the thermal system. The indicator should change in an increments of 0.2 seconds. Now it is all about our LabVIEW programming block diagram. Right, so we must have to separate out all those our. I could also show this as a views icon so that it will take less space. So this one is for fluid, this one is for thermal, for the thermal, for the fluid, and we have a tab control in here, and capacitance, initial head resistance, magnitude, head resistance. So this will be our fluid system, and the capacitance one will be our thermal system. So for now I will choose a case structure, so it will switch between the fluid or the thermal ones. So now it is inside the fluid, and these ones are inside of thermal ones. Right, we can also elongate it, and we can do one more thing. We can place it within while loop as well. And now, as from the instructions, we have to make increments of 0.2 seconds. So we will place a weight which is like create a constant. 2000 is like 2 seconds, so if I decrease it, so now it is like 0.2 seconds. And then what I need to do is, in here I have to build up the impulse input or the fluid system step input or an impulse input equations depending upon these selections. So here it is a thermal ones. So again I'll shift back to the fluid. So first of all I'll build up the fluid system equations. So I'll place a case structure. So now we know on the true section we have, I could also show you again, if it is true then it is impulse, if it is false then it is step, right? So right now it is true, then we have to write down the equations for the fluid system step input, so, or the impulse input. So now I have just shown a simple thing in here that we have to build up this mathematical model, which is quite a simple thing to do. So here, as for true and false, I have shown in here about these. I have just connected out these things and I have built a simple model. So now what I have done in here is simply I have drawn the equations for the fluid as well as for the thermal system, and I have just connected it with these inputs. You can also do something if you are like morely used to of it like MATLAB or like something, then you can use a formula node, and then here you can just define your inputs, add an input, and then you can define as temperature input as a whole name, then it will take as an temperature input. Let's just place that in here, and then I could show you that this one like here it now can be connected with this one, but you have to mention the temperature input in here, then it will be considering it as an input, otherwise it won't accept it. And then you can use it for defining the inputs as thermal step and impulse and fluid step or impulse, but I prefer to do it like this way since we are using a LabVIEW program. So I have just built up this model. One thing is still remaining in here that we want to mention. So here it is at T that we need to connect in here. So T basically divided by RC. So to T divided by RC in here, we must have to bring out something new. We are using some elapsed time in here, right? Elapsed time of 0.2, because right now the time is in here. So again so I'll place that in here, elapsed time. So I'll connect that in here as thermal, and also connect with this one, which is our fluid system. So now it is all connected. We can also reset it by creating a control in here. We can elongate this one, show it like this. So here we can reset it as well as, so place that in here, and we can also, after setting this, we can also replace it with something silver ones. So go to boolean, go to buttons, and there we will find out a refresh button. So instead of saying it is a refresh, we can say reset or reset, yeah, reset time or anything like reset time, right? So we can also remove the label, and this is what we can show in here. Again, just go back in here, and now what are the other requirements we have to check? So if we come in here, we have now all these things, and now we want to show it into a temperature. The fluid system, and it is a thermal system. So I'll connect that in here, and in this system I will show it as a 0. I'll show it as a 0. So now we have created this system, but still it is not it cannot be executed because of this error that we have not connected it. So a warning message should appear if the temperature or the head reaches more than 70% of their allowed values. So here the allowed values are here, but still we want to run it before running this system. Right, and add a frame before. So I'll increase this and put it inside. So unless this structure is not completed, this won't start out. So obviously these values will be pop up and we can see these values, and after ending out we need to do something else as well. At a frame after, we need to reset out all these values, right? So what I'm gonna do is application control, I'm going to this VI, then I'm going to create a method VI default values, reinitialize all to default. I'm going to this as a reference so that after once we have completed all this system, all the values will be reinitiated or reset to zeros or their initial levels. Alright, so now one more thing is in here, we have to show if they are exceeding the 70% of maximum values, then we need to show a warning message, right? So for that purpose, what I'm going to do in here, I'm going to use a property node, a value, similarly head, create property node value here. Now I'm going to use this divide function, or instead of divide I can also say I will use this multiply function. I will multiply that with 0.7, since we are considering just only the 70% of the value, right? So if these values are like greater than temperature, greater than maximum, oops, not this maximum, I have to connect it out with this one, and again like this for the tank, for the fluid system, the maximum head, and then again I'll show something as I'll use comparison and then select function in here. I'll make a copy out of it, and then I'll use a select and then in here as well. So now I will use a string constant. For false, I would say here as a thermal system. I could reduce its size so that it will fit within the screen. I could give it input, and similarly as false system in here. Similarly, I would make a copy out of it, and here this time I would say fluid system, and here I would say I'll call it maximum head, right? I will again connect that in here. So now I have the two outputs, but still I want to show it on only one output. So I'll go to the front panel, and here I have a silver, and then again string output. I could remove its label, down the button, increase its size, show it in here. And one more thing is I could make it justify to center, so that all the values will be, or all the message will be centrally aligned. So I'll place again a structure in here, and I'll connect that with this tab control, so that either it is a thermal or a fluid system. So I'll connect out with this string output, and for the warning sign for the fluid, this should be passed to this one, and for the thermal ones, this should be connected. So on only one string output we can have the both messages. So now what are the next requirements we have? The user should be able to reset the time as he changes the input type, right? So here we have already set that. To reset the time, I could place that in here. And the next thing is the program will be stopped if one of the following four conditions is met. The maximum temperature is reached, alright, and the maximum head is reached. If the program for a specific input has run for a specific time target, if the user clicks a safety button. So again, go back and place a safety button in here. Again, we can choose it from the silver ones, booleans, and let's just say stop or safety button. We can make the size equal, and we can also align them. I need to remove its label. Now it will be properly aligned in here. I would say safety button. Right, so this could also close it, or the maximum value. Here I could use the numeric and the compound arithmetic and set its change the mode to OR. So we have multiple conditions in here. So we have greater than or equal to sign for the maximum temperature. Oops, we have to compare it with this maximum temperature limit. So we will give this out, this one in here and this one in here, and again we have to compare it with the maximum head. I have to delete this because it automatically grabs the wire. So yes, so we can take the wire because it is connected to in here, so this will be the same. So we have these conditions like this in here, and then the other condition that we have the stop button as well. So I could place that back and just connect it in here. We have one more condition, that if a particular system is run for a particular targeted time, then it should also be stopped. So let's just suppose that our elapsed time in here, we set it, let's just say comparison greater than, let's just say if it is run for more than 2 seconds, or let's just say, no, not just 2 seconds, because right now it is elapsed time we have set 0.2. so yes, if it is more than 2 seconds, or if it is like 2 minutes, then we have to add one more 0. Then we can also connect that in here. Similarly, we have to give it into the fluid system as well. I could make a copy out of it, and I would select it in here as well, so that for a particular system we can also change its values. So let's just say like this. For this system I would say for 1 minute, for 1000, for 1000 supposed to be 1 second, for the 10 seconds, not for the 1 minute, it is just 10 seconds, and it is just for 20 seconds, right? So these all will be connected to with this single one, and now it is ready to execute. So if I go back and if I run my system in here, so first thing it asks me about the temperature input. So I would say the 30 is my temperature limit, and the head is 10 meters, and I will give the input. Now I have to change the values. So right now it is a thermal system, capacitance is 2, resistance is 2, temperature input. So right now it started increasing. The initial temperature, let's just say 0, but I'll say 1, but I'll increase its input. So the maximum temperature limit is our 30, so we have to check if it gives us, so warning is also given like above 70% of the maximum temperature. So let's just check out if the program just stops after 30 degrees or not. So as soon as it should pass 30 degrees, the system should also automatically should stop. So yeah, it is stop and it is reset to it because it was exceeded the limits. So we can set the other things as well, like we can also add some Excel sheet where all the values, the time, and all the other properties were also included. We can add many more things in here as well, like just for the beauty we can add an images on the background. We can add we can change the background as well. We can set these out as sub-VIs, which is very important for the functionality or the modularity of the system. And we can do many more things as well to just make it more like an application level. So you can find out all those things in my other videos as well. So the links are given in my description, so you can check out all those programs to learn more about the functionality of the LabVIEW programs and how the things works in LabVIEW. So I hope this will be very informative video. If you like this video, you can just subscribe to my channel. Thank you so much.